Hello everybody and welcome back to the series of videos for chapter 9, Inferences on two samples. In this video I will talk about hypothesis testing and confidence interval for the difference between two proportions. So we're switching our focus from means to proportions, from quantitative data now to categorical. Okay? All right, let's take a look at the following problem. We have a problem about the BMI, the body mass index, and we have the following survey. We have 750 men and 750 women who said that their BMI was normal. Okay, the goal of this problem is to determine if there is a significant difference in the proportion of men and women who are normal weight. So let's write all of the information so it's easier to see what's going on here. Let's take a look at the information about man. So we have a sample of 750 men, and out of those we have 203 who are normal weight. Okay, and then for women we have the same sample size, and the number of women with normal BMI is 270. Okay, so our goal is to determine if the difference between these proportions is significant. Let's go ahead and actually compute our proportions. So for proportion of guys who have normal BMI, we would do 203 over 750, and let's see what we get here. Okay, so let's say roughly 27%. Okay, then what about ladies? So proportion of all ladies with normal BMI in this sample would be 270 out of 750. That gives us 36% exactly. Are these proportions different? The answer is yes. Are they different enough? Well, that's what we're going to determine. Okay, so let's go ahead and do hypothesis testing. How do we do it? The first step is to set it up. The null hypothesis will always say the two proportions are the same, or there is absolutely no difference between 27 and 36, or the difference is not significant. Okay, then for the alternative hypothesis, it depends on the problem setup. You could have a left tail test or right tail test, but in our case, how do I know that this is a two-tail test? Because it says right here, is there a difference in the proportion of men and women who are normal weight? Different means that I'm going to use P1 is not equal to P2. Okay, and that's my setup. And what is the calculator command that I'll be using? I have two samples, two proportions, so that's two proportion Z test. My samples are large enough for me to conduct this testing, so let's go to our calculator, and we're going to go to stat test, and we're going to search for two proportion Z test, command 6, and now we need to plug in our numbers. So first one is 203 out of 750, and then what about ladies? 270 out of 750. Okay, all right. Now I'm looking at my alternative hypothesis, and it's not equal to, so that's what I'm going to highlight. And let's go ahead and compute our p-value. Our p-value is 0.000197, right? Let's call it that. So p-value 0.000197. That's a very small p-value. Oops, that's not what I wanted to do. I wanted to highlight it. Okay, this is a small p-value relative to our alpha level, which is 10%, right? 0.10, so that's our level of significance. So what is our conclusion? Our conclusion should be reject the null hypothesis. There is very strong evidence to suggest or to claim that there is a difference in the proportions of men and women with normal weight or normal BMI. Okay, so what does it really mean? 27 and 36, are they significantly different? Yes, they are. And you might have had that feeling before you even conducted the hypothesis test and then say, yeah, well, it feels like a lot. It feels like a big difference, right? And the answer is yes, it is absolutely significant. This is your proof right here. This p-value has been this small, okay? So that is your hypothesis testing for two proportions. And now let's go ahead and do the following. Let's actually construct two proportion z test. Okay, two proportion z test and see what it tells us. If I do two proportion, oh come on, work with me here, pen. Two proportion z interval. Okay, let's go back to our calculator. The good news is once you plug in your numbers for the z test, all the numbers are already automatically in the second command. So we need to find two proportion z interval. Let's look, keep looking. There it is, two proportion z interval. Press enter and look. All of the numbers are already there. 203 guys out of 750 and 270 girls out of 750. Now let's switch our confidence level to 0.9 because our alpha level in this case is 0.10. And let's go ahead and compute it. Okay, so what do I get here? Negative 0.1286, negative 0.05. Okay. Let's write it down, negative 0.1206 and negative 0.05. All right, how do I interpret this? Well, this is my interpretation. Let me rewrite the following confidence interval as follows: 5% to 12.06%. Okay, now you might say, why is there a negative there? Okay, why do we have two negative numbers? And the reason is the following. If you go back up there, let's take a look. We have two groups. One where men have smaller proportion of surveys whose weight is normal than women, right? This is smaller than 36. So if you were to subtract 27 from 36, you're gonna get a negative number, okay? And there's nothing wrong with that. So two proportions, the interval tells you how big the difference is. Hypothesis testing tells you if there is a difference between the two proportions, and two proportions, the interval tells you what the difference is, okay? And the difference is right here. So how would I interpret this? I would say we are 90% confident that the difference between proportions of men and women with normal weight or normal BMI, BMW, I wish, BMI is between 5% and 12.06%. Okay, that is your interpretation. Again, just like in the example what we had to sample means, whenever you have a confidence interval that does not contain 0, this is good. That means we should have rejected the null hypothesis, and we did. Hypothesis testing tells you if there is a difference, if the difference is significant, and the interval tells you what that difference is or where it's contained. Okay, it's contained between 5% and 12%. Okay, so that is your interpretation of this situation. That means, yes, it looks like women overall have healthier weight. Okay, by how much? By on average between 5 and 12%. That's the significance. Okay, now let's take a look at the problem where we might come up with a different conclusion. All right, let's see what's going on here. Here we're talking about two different groups that are based on age. So let me write down my group from 25 to 34-year-old. That's my group number 1. And then I have another group, 45 to 64-year-old. Okay, so two groups of people, and they answer the following question: do you wear a seatbelt? All right, so let's see what we got here. Okay, we have a sample of 1,000 drivers that are in the age group from 25 to 34 years old, and out of those, 27 said that they buckle up. So 27%, not 27 people. So 27% out of 1,000, that is 270. Okay, if this number wasn't as easy to compute, you would actually have to compute the number of people who responded. Now in this case it's easy because it's 1,000, right? So what about the other group of people? Here we have 1,100 people, and out of those, 330 said they use seatbelts. Okay, at the 10% significance level, do the data suggest there is a difference in seatbelt use between drivers in these age groups? Okay, same as before, let's set up the null hypothesis. Okay, the null hypothesis would say P1 is the same as P2. The alternative hypothesis, okay, how do I know what the alternative does say? Okay, do the data suggest if there is a difference? Okay, that's my line that tells me what to use, and here I'm gonna do P1 is not equal to P2. Okay, all right, let's go ahead and plug these numbers in our calculator. I'm gonna go back to stat test to proportion z test. Okay, so 270 people out of 1,000, and then here we have 330 out of 1,100. Okay, not equal. Let's compute this. Okay, the p-value is 0.1285, right? Okay, so I did 2 proportion z test. I got a p-value 0.1285. That is not big. Let's take a look. My P1 is 27%. My P2 is 30. these numbers are not significantly different. Looks like the 45-64-year-old group has a little bit of a higher proportion, but not by a lot. Okay, so the p-value says it's 0.1285. Our significance level is 0.10. This is bigger. So what do we do? What's our conclusion? Do not reject the null. Do not reject H naught. There is insufficient evidence. There is not enough evidence. To suggest what? Well, you can just copy this statement. To suggest there is a difference in seatbelt use between the drivers in these two age groups. To suggest there is a difference in the seat belt use between the drivers in these two age groups. Okay, all right, so that is your conclusion. Remember, your conclusion should always be in the complete sentence that makes sense to somebody, let's say from outside of the statistics class. Okay, if they can read your final punchline and understand what happened, then you did good. Okay, all right, so we've done hypothesis testing. Let's just see what we would have if we were to run two proportion z interval. What happens? Let's go back to our calculator. We're gonna go to stat, test, and two proportion z interval over here. The numbers are already in it, right? 0.9. Okay, let's go ahead and compute and look what happened. We got an interval that has both negative and positive number, and a 0 is there, right? So this is negative 0.0624, 624, positive 0.0024. Okay, what does that really mean? It means that for some samples, the proportion of people that use seatbelt will be higher in one age group, and for other samples it will be higher in the other age group, and for some samples it will be the same. That's why there is a 0 there. Okay, so this is actually consistent with the conclusion from the hypothesis testing. It says that no, the data does not support the claim that there is a difference in these two proportions. Okay, so whenever you get negative, positive, that means your hypothesis testing is not rejected. Okay, and you don't even need to interpret this interval because it's actually meaningless. Okay, we don't need to write a full sentence because, again, there is no data that says yes, for sure there is a difference in the two proportions. All right, so we talked about two problems where we reject the null and we have a confidence interval that's actually meaningful, and in the second problem we fail to reject the null, and the confidence interval that we construct contains a 0, so that means our conclusions are consistent with both hypothesis testing and the confidence interval. All right, so this is how you would solve problems with two proportions. In the next video, I will talk about two samples that are dependent, that are paired data. And that will be the last video for this chapter. Thank you for watching.